Good evening, guys. This is a continuation on my previous video. Uh, this has already been discussed about the two previous videos, I think so. But anyway, this is the last one that I'm going to discuss about remaining cargo to load or cargo to load, because I want to emphasize that uh, the viewers will put in their mind on how to get this remaining cargo to load or cargo to load. So let's start, guys. This is the problem. The last one was example 4.6, and this one is 4.7. So the vessel MV Panama is floating in a draft of 13.25. So meaning, again, I'll explain to you again, so you will have an idea. Just please bear with me. Okay, then I'll get here. Open with what is this? So this is a ay, sorry. This is colors. Put it this way. Okay. Okay. This is a loading sequence or loading plan. This is a capsize vessel. Take note, I will just give you an idea. So it's loading in Port Walcott, Australia, and to be discharged in South Korea. So our example is only up to hold number 7 from 1 to 7, okay? Since this is a capsize vessel, so this is the idea, a formal form of loading sequence, okay? And this is the sequence. This is the number of pour from 1 to 20, and this is the number of holds to load, and these are the quantity of cargoes to load in each hold. Okay, so to make it a shortcut, at pour number 18, the foreman will stop operation because they will ask the chief officer and the drop surveyor to make a drop reading, so that we will so that the chief officer and the drop surveyor will compute on how much remaining cargo to load. So in this case, at 418, it says drop check and trimming, drop check and trimming, okay? And the initial, uh, forward and up drop is, forward is 1705 and up is 1745, okay? 1745. In this case, the drop for drop checking or trimming is 13 to 5. Okay. It doesn't say here the trim. doesn't say here the trim or he has a trim. So we just assume that he's even killed because this is the main drop of 1325 with the density 1.008. So it doesn't say if he has a trim or trim by the head or trim by the stern. But this drop is 13.25, which is the main drop. And in this case, okay, he stops at 418 for drop check or trimming, and this will be his initial drop forward and out. And they have a trimming hold is 199, and this is the remaining cargo to load of 4,000. But in this case, the initial trimming for drop check is 1325, okay? So, and the density is 1.008. So, I go to my program. You put here 13.25, okay? So, to the program, you put here forward 13.25 and up is 13.25 and the actual reading at midport is 13.25 and mid starboard is 13.25, okay? So this will be your mid drop as stated in the example or the exercise is 13.25, okay? Now, you put the density of 1.008 and at completion the density is also 1.008, okay? So you have now your mid drop. Take this out first. And it says the final mid or departure drop is final drop, which is the departure drop, and this is your initial. So your departure drop is 1325 and your sinkage is 0.25. So what we do, you put here 1350, your departure drop 13.50. You press enter and your departure drop is 13.50 and your sinkage is 0.25, which is this one 0.25, okay? Now the next step is how to compute for the remaining cargo to load or cargo to load, and the formula is sinkage times TPC times 100. But take note, the TPC has already interpolated using this density 1.008. Well, the density of 1325, the TPC should be, take note, 1325, the TPC should be 6442. 6442, this should be 6442. So what he did was to interpolate the TPC to duck water, okay? And I don't understand why he has to use 1.012 when instead the density is 1.008, okay, until completion. But he put here 1.012 until completion of 1.012. But anyway, we just discuss this part. So he wants to adjust this duck water TPC to 1.012, which is 63.33. So TPC times local displacement over 1.025, and the TPC of 13.25 is 6.4 times your local density of 1.08 over 1.025 is 63.33. This should be salt water of 1.025 because of this formula. If the value, if multiplied by your local density over salt water of 1.025, the resultant should be fresh water. This is not, this should be 1.025, and this should be 1.025, and this will be your TPC of salt water. Now take note, the TPC of 1.008 is more than the salt water of 6.33. Why? Because this is salt water. That's why you have less TPC here. Because you came from density of 1.008 and you will go to 1.025. That's why you have less TPC here. If from salt water you go to your density of 1.008, then you have more TPC here. That would be 6.44. That this one should be salt water. But I don't understand why you have to interpolate the TPC. For me, it's not appropriate. But anyway, I will just proceed to the equation or the operation. Now, this is the formula for to get the cargo to load or remaining cargo to load. That is sinkage times TPC times 100. The sinkage is 0.25. Your TPC is 63.33, which is this one. Multiply by 100, and you get the value of 1583.25. So his answer is cargo to load is 1583.25. Now I will what's the term that I will oppose this value, and I would show you the operation of this program. Okay, take note, your initial drop is 13.25 and your density is 1.008, which is your mid of 13.25. That will be your mid. Okay, but in this case, again, it doesn't say any trim, or it is trimmed by the head or trimmed by the stern, but this is, I believe this is the mid drop of 13.25, okay, of floating in 1.008. That is your tons per cubic meter or your density, local density. So I put here the local density 1.008 with your mid of 13.25, and after completion your density will also be the same as 1.008. Okay, and according to the example, its departure drop or final drop is 13.25. That's why you put here 13.50. Okay, that will be your departure drop, and with this departure drop you interpolate the TPC. This is my program. Okay, with this departure drop you interpolate the TPC, and the interpolation of the TPC is 6455, which is this one. Okay, I never use this one, but I always use the final mid drop and interpolate the TPC. Then you will have this through TPC of 6455. Now, let's apply the sinkage. Sinkage is uh, uh, sinkage is the weight is again the weight or cargo is sinkage times TPC times 100. Okay, so this is the weight. I say sinkage is K8, letter K, and row 8. So this is the sinkage times TPC M3. This is the TPC M and row 3 times 100. Then you have this figure. Okay. Take, to repeat it, I would say sinkage. You click the sinkage. That is 0 to 5 times, or you multiply by your TPC. This is a TPC. Click this one. Then multiply or times 100. Okay. Then you will have 1613.7 metric tons recommended cargo to load for trimming. Okay. So I scroll down and put it here. So just round it up. That will be 1614. Okay. 1614. Press enter. What happens if you load 1614? The results after loading 1614, look at the mid 13.5, which is exactly here, and your sinkage is 0.25, which is exactly this one. Now, let's say the example is a you load 15, let's say 1583, okay? 1583. Let's put it this way, 1583. Okay. 1583. 1583. Okay. For the sake of computation. So instead of this figure, you put this one. So I put here 1583. And look what happens to this figure. Okay. So I press enter. So when you load 1583, what are the results after loading 1583? Look at your mid drop. It's not exactly of 13.5, which is less, and your sinkage is less of 0.25, then you have your 0.4. Why? Because the amount you put is less than this one, the recommended cargo for trimming, but he computed only for 1583, which is a difference of, okay, difference of how much? 31 tons. So you're short of 31 tons instead of using this one. Okay, so for example, we'll just use this one, 1383, just to see you the difference. Okay, so he says then go to trim modes 2 and take note that the remaining cargo to load is 1583, and your trimming hold is 1 and 7. Okay, and let's say for example you want to discharge depart at even kill, no trim, put 0, and the recommended cargo to load for number 1 is 682, and number 7 should be 901. So number 1 should be 682. Okay, put here 682, 682. Okay, and number 7 is 901, and your departure drop is okay. That's exactly 1350, 1350, and your form number 6, your take note that number 1 is 682. You have 682, put the LCG, and number 7 is 901, put 901, and the LCG, and your departure drop is 1350. Okay, exactly, and your deflection is 0. Then you go to the trim table. Number 1, take note of the trimming table. The cargo to load is 1583, number 1 is 682, and number 7 is 901. Now from hold number 1, at your loading manual, you look for the forward and up correction, and number 7 also look for the forward and up correction. Now take note that forward is 1349. So what you do, you just adjust this forward correction. This is your forward correction, so you adjust this one. For example, you make it 6.2. 6.2. Take note of what happens to forward drop. You are now trimmed by the head, but it doesn't say so. Okay, doesn't say so. It's even kill. Let's say 6.3. So we put 6. Okay, 6. That is trimmed by the stern. So we'll put 0.08. Okay, put 0.9. And you put 0. 0.9, that will be 1. Okay, that will be 1. Then you have even kill. Okay, 13.5, all even kill. So you have to do is adjust this one. Then, okay, there's another solution here. First, you load in number 1, on number 7. Number 7 of 901. The same correction of negative 1.9 and 5 here. And number 1 is you load 682, and forward correction is 6, because error adjust this one, that's why 611, and up is 3. Okay, this is, you can, okay, that's why 611. And this is the initial drop forward and up. Once you load number 7 of 901, after complete loading, 901, then this will be your initial drop of 1308 forward and up of 13.70 up. Carry this down, then you load number 1 of 682. Once completed loading 682, your forward drop will be 13.5, up drop will 13.5, trim 0, and your main is 13.5, and you have 0 deflection. Okay? And so with here, you just the initial upper checking drop survey, the density is 1.608, your initial drop forward is 13.25, up is 13.25. Now you apply now the low cargo to load in 1 and 7. So in number 1, you load 6A2, put there 6A2, 6A2, and number 7 is 901. So put here 901, 901. And after completion of loading, the density is 1.008, 1.008. And your departure drop main is 13.5, and you have an even kill. Okay. Okay. This one is exactly the same drop, but take note, if you use this figure, you will be short of 31 tons, because according to this program, you should load 16.14 to be exact, and you will be short of 31 tons. But you will have the final drop of 13.5. Okay, I will show you again. Okay. This is the recommended cargo to load for this program. Let's put 1614, okay? This one, 1614. So that we will not be short of 31 tons. So I put 1614, 1614. And take note, the exact mid drop is 13.5 here. And the sinkage is 13.25, which is exactly this one, if you use 1614 as recommended by this program. So let's continue. This here, this is the actual cargo to load for trimming, then go to trim holes 2. So you go to trim holes 2, take note of the remaining cargo to load of 1614, and we have a trimming hole of 1 and 7. So what will be, then you have a 0 trim there, no list, no trim. And recommended cargo to load for number 1 is 695. Okay, so we put 695, 695. And number 7, you should load 919. So you go, what is number 7 here? Round it up, that will be 919, and your departure drop is 13.5, up is 13.5, 0 trim, and 13.5 mean. And you have 0 deflection, which is this one. This is a very accurate program. And take note here, you load in number 1 of 695, apply the LCG, and number 7 is 919, apply the LCG, and your departure drop would be forward 1350, up is 1350, your 0 trim, your main is 13.50, and you have 0 deflection. Now take note, again, Where is that? Okay. If you load If you load this figure of 1583, you will be short of 31 tons. But if you use 1614, you will have exactly the same drop here on mid, the same sinkage, and you retain this 31 metric tons. So what you do, for example, this one, okay, put equals, because this is the one you're going to load, okay, so click, and you will have figure of 0. You will not be short of 31 tons. You have exactly 1614 metric tons, and you will have the same drop of 13.5 even kill. Okay, so trim holds 2, you have the same drop there. Then we go to by trim table. Okay, by trim table, take note of the cargo 1614. Number 1 is 695, number 7 is 919. We still maintain this correction forward and up, and your drop will be 13.5. Okay, take note, we never touch this one or edit this forward up correction. We retain it, and the drop forward and up is 13.5 even kill, and no list, no trim, and look at the deflection is 0. Okay, and it also the same with this here. In number 7, you load 919. This one, forward correction is the same here, and up correction is the same. And number 1 is 695, and the correction is 611, and up correction is 3. Okay, so this is your initial drop of 1325. You load the number 7 919. After completing loading 919, this will be your initial drop. Forward of 1308, up 1371. After loading number 7, you load the number 1 of 695, and your final drop would be 1350. Up drop is 1350, trim is 0, and your main is 13.5, and your deflection is 0. Okay, almost the same, exactly. Then we go now to form number 7. What is form number 7 is how to find drop and trim when handling weights involving large changes in main drop. So this is your density of 1.008, which is this one. Okay, then your initial drop of 1325, which is this one. Okay, your main drop, and you load now your holds, hold in number 1 and number 7. So number 1, how much is number 1? Okay, you load number 1, 695. Footer 695, enter. And number 7 is how much? 919. So you load 919, and your final density is 1.08, which is this one. Final mid, and your density should be 1.008, which is this one. And this is your main drop of departure of 13.50, and you have here almost even kill. This one should also be, this is only the mathematical equation, that's why you have 13.1, but actually this is even kill, and look at your trim is 0. Okay, so again, I would recommend, as what the program says, that you load 1614. Okay, then you will have no shortage of cargo here. Okay? Now, if you put this amount again of 13,1583, okay, which is 1583, put this one 1583, and you will have a shortage of 31 tons, but you still have the same drop of 1350. But I would rather use this 1614 and you have the same drop. Okay? So that's it, guys. I hope you like this video. Please click the like button, share, and subscribe. And please don't forget to click the notification bell. If you have any questions, please write on the comment section. And if you request for a, a copy of this program, please write me in my email, and I'm glad to give you it to you for free. Thank you for watching, and good night.